This example number 5 is indeterminate. It's very obnoxious. Some functions are like this, where you have to visualize the graph over plugging stuff in. See, check this out. If I plug 1 in, I will get 1 over 1 minus 2 over 1 squared minus 1. So what does that result in? 1 over 0 and 2 over 0. Which you would naturally think, oh, that's just undefined, like not indeterminate. So it doesn't exist. It's because if you get something like this, then you know that the limit does not exist at D and E. But, this is why I don't like it. It's one of those exceptions. Let's think about each of these individually. So if I think about this one first, what does that graph look like? Well, I know it has a vertical asymptote at positive 1, and it has a horizontal asymptote at y equals 0. Is everybody okay with what I've said so far? Okay, this is at 1. All right, the function goes like this and this. Okay, and you can check that just by plugging in a few x's. Like you could plug in a 0 right here to this thing and see what you get. That would be 0 minus 1, which is negative 1. Then you have 1 divided by negative 1, which would be a negative number, right? So therefore, you know it's on the bottom. It's below the x-axis. This one is above the x-axis, and you can know that by testing the number 3 or 2. Yeah, because that's a 1, right? The asymptote is a 1. So let's test 2. We plug 2 in right there. It'd be 2 minus 1, which is 1. 1 divided by 1 is 1. Positive 1. So there you go. There you have it. Now, if I approach 1 from the left-hand side, what is the function doing? It is decreasing a lot, right? It's going down, 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 down to negative infinity. If I approach it from the right-hand side, what's my function doing? It's going up to positive infinity. So you would say that the limit of this at 1 is infinity. Very annoying. I know. Like what? Why? You just do. Okay, so negative infinity, infinity. It approaches infinity. The function approaches infinity for this one as I approach 1. So what's happening with this one at 1? So we look at that one. And we're looking at these individually, students, because you can separate them. You can say the limit as x approaches 0, not 0, 1, of 1 over x minus 1. And then you can subtract from that the limit as x approaches 1 of this guy. Oh, that's supposed to say minus 1. So we got this one. This one is infinity. So what does this next one equal? What does this one give us when we look at its graph? So we look at its graph. Oh, man. You're going to be so annoyed, I know. What are the asymptotes, the vertical asymptotes for this guy? Yeah, because we can factor the bottom to be x plus 1 and x minus 1. That's a difference of squares right there. So we have a positive 1 and a negative 1. And so I go positive 1, we'll make our negative 1, and here's positive 1. Dead. Okay. Now, where's my lines? Well, how do my lines look? Well, it's going to be this or this. But what happens in the middle? Okay, so we pick numbers and we plug and chug. So I'm going to pick a number before the negative 1, which will be negative 2. I'll pick a number after the positive 1, which I will say is positive 2. So we can see what those lines look like. So if I plug in negative 2 into this, what do we get? Negative 2 squared is?
4.
Positive 4 minus 1?
3.
2 over 3. Positive or negative? What? Positive, right? So it's positive. It's up here. Is everybody good? Okay. Then I have the other side, the right side. Let's plug in the 2. 2 squared minus 1 is 3. 2 over 3. Hey, same thing. It's also positive, huh? So we have this. Now what's happening in the middle? Now the middle, from experience, I know the middle either is going to look like this, or it's going to go like this. And actually goes through the horizontal asymptote, which is very obnoxious. So let's pick a number right here and a number right here. Let's do negative 1/2, or you could do 0.5, I suppose. same thing, and positive 1/2. Let's try negative 1/2. If I go negative 1/2 squared, that would be a positive 1/4. Right? You guys still with me? I'm sorry, I'm doing some mental math because I don't want to write it all out. So that's positive 1/4 minus 1, which would be a negative number, right? Yeah, and then so 2 divided by a negative number would be a negative number. So we have a negative number right here. I'm just going to put a random dot down there so it's below the x-axis. Now what about 1/2? Is that going to be the same thing?
Yeah.
Yeah, because it doesn't matter if it's positive or negative because you're going to square it. When you square it, it gets rid of the negative and it's going to be the same number, right? So I also get a negative, so it's down here. So I know that my function looks something like this. I wonder if it actually hits the origin. We would have to plug in 0 to find that out. Let's find out. Oh, snap. What happens when I plug in 0? I plug in 0 right here. I get negative 1. So I have 2 divided by negative 1, which is?
Negative 2.
So this x or y-intercept is negative 2. Okay? That was kind of simple for figure that out. All right, so this is that function. So here's 1 right here. As I approach 1, what's my function doing? Down to negative infinity. As I approach 1 from the right-hand side, what's my function doing? Going to positive infinity. So we have the negative infinity, positive infinity thing again. So guess what? You're subtracting infinity. And what is that right there? That is an indeterminate form. Holy junk. Yeah, it's very obnoxious. Go ahead, ask your question. What is it, Bree? What Bree did is she found out a different way how it's indeterminate. She took those two guys. Let's see. We have 1 over x minus 1 and then 2 over x squared minus 1, which actually is x minus 1 times x plus 1. And she made this one have the same denominator, so x plus 1, and so that would be x plus 1 on the top. Wow, that's so sloppy. But then she had, x plus 1 on the left side, and we're subtracting 2. And on the bottom, we had the same denominator, so we don't have to write it twice. We have x plus 1, x minus 1. And then at this point, this is where you plugged in the 1 to see if it would work. Now, if you plug in the 1 for this, you're going to get a 0 on the bottom, and then we're going to get a 0 on the top as well. You got 0 over 0, which is also indeterminate. I like that too. Oh, very nice. So we can think about it graphically, or we can do a little bit of manipulation and then see what we get when we do that. Let's see. What do we get? Oh, so when we get x minus 1 on top, and on the bottom we have x plus 1, and then x minus 1. She plugged it in and it got an indeterminate form. But here, check this dude out now. Now that she has already done that, she's already further along in the problem. Now that we know that it's an indeterminate form, what do? Use some algebra. See if you can cancel some stuff out. Can we cancel stuff out now?
Yes.
Yeah. Peace out. Peace out. They died. So now we have 1 over x plus 1, and we got to find the limit of this as x approaches 1. What does that equal? 1/2. Okay? Ask me questions. Let's go. Now I'm going to plug it into our calculator just so we can look at this graphically and then numerically, okay? So the top, let's see, it was 1 over x, was it x plus 1?
Minus
1 divided by x, you said it was plus 1 or minus 1? Minus 1. And then from that we're subtracting 2 over, and I'm going to use parentheses again, x squared minus 1, close parenthesis. So that's our function. I want to look at this graphically to see if we can see the limit in there. So I'm going to hit graph next. So there's our graph. Now you can see there's an asymptote at -1. But we're approaching, our limit is approaching +1, right? Look at +1. I don't see a hole there, but your graphing calculators won't show you a hole. But it looks like the limit does exist right there. So what we do is we go over to our table. We hit second and then table. Hopefully my table's empty. It's not, so I'm just going to keep hitting delete. I'll delete my table right here. Now, if you go to your table and there's already a bunch of numbers there, you need to go to second window, which is table set, and you need to tell it to ask you for the independent variable, which is the x. Independent is the x. So you tell it to ask, then you go back to your table, second graph, and then you could put in your own numbers. Now, I want to approach one from the left, and I want to approach one from the right to see if we're going to get the same answer. And what's the answer that we're looking for? We already found it. It's right here. We're looking for the answer 1/2. So now we're analyzing it numerically. So let's approach one from the left. So a number that's really close to 1 on the left is 0.9. If I plug in 0.9, I get 0.5263. Now what's a closer number than 0.9? 0.99. I just plug in that, I get 0.5025. What's an even closer number than that? 3 nines, right? Boom, I get 0.5003. Now I'm going to go even closer. Let's do 4 nines. That's really dang close. Now, is our calculator infinite or finite? It's finite. It exists in our world, right? And so therefore, there's a point where this calculator is going to start rounding our number. And look, it rounded it. What would happen if I picked 1? It'll give me an error. Why? Because it's undefined at that point. Let's approach 1 from the right-hand side. So then that would be 1.1. And then give me a number that's even closer than 1.1. Yeah. And then one that's even closer. And then one that's even closer than that. And look, the calculator starts rounding it to 0.5, which is the limit that we found. So we just analyzed this problem graphically, numerically, and we did it algebraically.